Two events are mutually exclusive or disjoint if they cannot occur at the same time. So in our 4.1 homework on the probability with your blood, the different types of blood, you cannot have both type A and type O blood. You can only have one. Therefore, those two events are called mutually exclusive. This is a definition you must know, and you must know how to prove it. And it's easy, but there's two different things we're going to be talking about, and you have to know both of them. So example 1, determine if they're mutually exclusive or not. Can you randomly select a female student and randomly select a female student who's a junior? Can you do both? Yes, so therefore not mutually exclusive. A person with type A blood and a person with type O blood. Yes, and your reasoning is you can only have one type of blood. The only way I could change that in this question is if I said type A blood and type negative. You can have A and negative because those are different categories. Okay, rolling a dice and getting an odd number, rolling a dice and getting a number less than 3. Are they mutually exclusive? No. What's an example that says they're not? Randomly selecting a person who is under 21 and randomly selecting a person who is over 30. Yes, you can't be both ages. So the addition rule is the probability of 2 or more events. So what we're doing is, instead of having a chart, we're going to be dealing with the same stuff we were doing in 4.1, but now we're applying the mathematics to it. Now, you need to know this right here. Sorry. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So if you have two things that intersect, think about your chart. When you had the big chart, you had two things that overlap. You would add up each column and each row, but then you'd have to subtract where they overlapped because you counted them twice. Does that make sense? Now, down here, if they're mutually exclusive, then it's this. What's the difference between the two? They're the same formula, by the way. What does it mean to be mutually exclusive? They do not what? Intersect, which means the intersection is, mathematically, it's 0. That's why it's not in that second formula. They're the same formula. So my recommendation is know that first formula, and then remember, if they're mutually exclusive, the intersection is 0. Okay? Because that's the same formula. Then you're not memorizing two formulas. All right. A spinner has 4 equal sectors colored yellow, blue, green, and red. What's the probability the spinner lands on yellow? 1 out of 4 or 0.25, yes. What is the probability the spinner lands on red or blue? So that's 1/4 plus 1/4. 1/2 or 0.5. Now, this seems very you're like, well, this is no different than last class. It's not, but when it gets more complicated, that's when the formulas are important, okay? All right, the spinner problem. What's the probability it does not land on green? So that would be your complement again. The probability is going to be 1 minus 1/4. 1 minus the probability that it does land on green. Green was an option, right? Yes? Okay. So it's 3/4 or 0.75. In an animal shelter, there are 8 dogs and 10 cats that are available for adoption. 6 of the dogs are female and 3 of the cats are female. If a dog or cat is adopted, find the probability it is a cat or it is a male. So the first thing you want to do is draw a chart. We know that there are a total of 8 dogs and a total of 10 cats. We know 6 dogs are female, which means how many are male? 2. We know that 3 cats are female, so how many are male? 7. How many total males do I have? 9. How about females? 9. Total of 18. Find the probability it is a cat or a male. So probability cat or male. So the math is the probability it's a cat plus the probability it's a male minus it's the probability of both. So that would be 10 out of 18 plus 9 out of 18 minus having both is 7 out of 18. Questions on that? All right, look at example 4. Suppose that the probability of A equals 0.42, the probability of B equals 0.38, and the probability of A or B is 0.7. Are A and B mutually exclusive? So, what is the definition of mutually exclusive? What math do we need to remember? A and B equals 0. So if I'm saying, are they mutually exclusive? You're finding what is the probability that both occur. If it's 0, they are. If it's not, they're not. What formula do I use for A or B? So this is the 2 things we've talked about today. We learned probability of A or B equals probability of A plus probability of B minus probability of A and B. And now you just replace each of those probabilities with the values that I've already given you. So 0.70 equals 0.42 plus 0.38 minus, and you can just put that as X. That's your unknown. And you can tell without doing any more math, it's not, because X is 0.10, so not mutually exclusive. And if I ask you to give your reasoning, what's your reasoning? Okay, that would be one way to put it. What's the other? The exact same thing that you said, A and B equals 0. Y'all said the same thing. Both of those are acceptable. You both use the definition. Does that make sense? Yes? Do I have example 5 written down in your notes? Huh? No? Sorry, example 6. No, there's supposed to be an example written down here, and I guess I forgot to add it to the notes. And why I put them both, I don't know. Okay, so example 5 is a survey of middle school students were asked, what is your favorite winter sport? The results were so we have snowboarding, I didn't spell snowboarding right, sorry. We have skiing, and we have ice skating. And they are in 6th grade, 7th grade, and 8th grade. Okay, we are going to find the probability they're in 6th grade or 7th grade or they like skiing. So this is kind of a three-way, and that's what the formula above this is for. So if you have 6th grade being your A, 7th grade being your B, and skiing being C. The probability of A or B or C is those three added up. And then you have to subtract each set of intersections. So minus the probability of A and B, minus the probability of B and C, and then minus the probability of A and C. Does everyone not understand that, or is everyone okay with that?
Do you have to do the A and B and C?
Oh, yes, thank you. All right, probability of A. So, by the way, you would have to also add up all of your columns and rows. That's 211, that's 171. This is 163. And then to the right is 155, 210, and 180. My total is 545. So the probability of A, probability of them being in 6th grade is 155 over 545. Oh, gosh. The probability of them being in 7th grade is 210 over 145. Sorry, 545. The probability of them liking skiing is 171 over 545. Okay, now let's start subtracting. What's the probability of both A and B, 6th and 7th grade? Can't do it, so therefore it is 0. Probability is 0. Was not a trick question. What's the probability they are in 6th grade and like skiing? Or 7th grade, sorry, 7th grade and like skiing, thank you. So minus 56 out of 545. Okay, how about 6th grade and like skiing?
Would it be 210, or how do you know it's not 56 out of 210? Or?
This is not given.
Oh, okay.
Right. It's out of everything. Good question. So what's the probability they're in 6th grade and like skiing? 41 over 545. And then what's the probability they are in 6th grade and 7th grade and like skiing? 0, because again, you can't be in 6th and 7th grade. Does everyone understand that? Does that make sense? Yes? And now literally you do the math. By the way, if you notice all the denominators are the same, just do the top numbers, find that answer, divide by 545. 0.806, is that what you meant?
Yep.
Okay.
Did I say 8?
I think you did, or that's what I heard, but yes. All right. So assume that following an injury you received from playing your favorite sport, you obtain and read information on new pain medications. In that information, you read a study that was conducted to test side effects. Use the following table to answer the questions. First of all, how many subjects were in the study? Total number of people. How do you find that? 192 plus 186 plus 188. So the ends at the top of each column. You don't have to add up all the numbers. It gave you each column totals. So 566. How long was the study? 12 weeks. Sorry, you answered that. I just realized that.
Why did you just say 12 weeks?
Yes, I'm ahead of the game.
She is very much. Okay, what were the variables?
Placebo, drug, and
Okay, and what else?
Did you say druggy?
what did you just say?
Okay, the drug or not getting the drug. So placebo, drug A, drug B, and what else? What are you looking at in addition to that? The side effects. Oh, I'm labeling these A, B, C, D, and they're numbered. Sorry. Number 4, what types of variables are they? Oh, sorry. So this is going back a long time ago. Qualitative or quantitative?
Quantitative. Oh, wait, the side effects?
Side effects.
Oh, qualitative.
Qualitative. This is the one that you might not remember. Nominal, ordinal, number, nominal, because I'm counting things. While you need to remember qualitative, quantitative, I won't ask the other. Just know that. But it's still good to review.
So you're saying that all the numbers are the nominal?
So the qualitative, the side effects, because they're a description, but I'm counting. They're countable. And remember, I can say 10 is twice as many as 5. So it's like, you remember all that nominal, ordinal stuff. Anyways.
How did you know that 4 was asking about the side effects and not the, like, drug and placebo?
They're all qualitative.
Well, yeah, see, the drugs are also qualitative, yeah. Okay. Are the numbers in the table exact figures? Are they exact, or are you having to, like, approximate? They're exact, so yes. All right. What is the probability that a randomly selected person was receiving a placebo? How do you find that? 192 over 566.
Added on to the other numbers, would you not add it all up in the study? 'Cause
What do you mean?
Doesn't that mean that 566 is just the placebo?
No. If you look at the top, placebo, N equals 192, that's how many people were given the placebo. Drug A, N equals 186, that's how many people were given drug A.
So are all
So
the numbers underneath that?
all those numbers are the different side effects for the placebo, for drug A, for drug B. Does that make sense? Yeah. Okay, look at number 7. What is the probability that a person was receiving a placebo or drug A? What do I do? No, or, not and. 192 plus 186.
378.
All right, here's where we're looking at an intersection. What is the probability they received a placebo or experienced a neurological headache? So what do I have to do? All placebo plus all neurological headache minus the intersection. So that's going to be 192 over 566 plus, you can write it out, but 34 plus 55 plus 72, that's everyone who received a neurological headache, no matter which medicine they were on, minus the intersection of both.
I did pretty good, see? This is why I was up until like 2 minutes. Okay.
So quick for us.
I think
I need it.
We're not giving.
Should you
crushing
need
it.
it?
I didn't print out my sources.
Oh, really? I did not do the API.
Let me shut it real quick.
I didn't know that.
Thank you.